This is the very first web page of Amazon. If any of you used Netscape Navigator, all right, that's a young crowd. But you can see that early on, Amazon was already thinking about recommendations and personalizations. It talks about Eyes, which is a tool that is recommending books and authors that you may like, right? And this is back in 1995. So you could say that this is an early recommendation personalization system at the company. When I joined, and of course, when we talk about recommenders, there is a publication last year which documents 20 years of recommender systems, and you could say that Amazon actually wrote the book on recommendations. It had contributions to algorithms such as collaborative filtering, specifically in the item-to-item category, not just user-to-user, person-to-person recommendations. So take a look at this publication. So when I joined personally, it was in the Search Inside the Book project. This was interesting because back then, we've taken lots of physical books, and at that time, we actually had to cut the books into pages, scan every single page, OCR the pages, extract the text, and my responsibility when I joined the company was building the search index over the contents of, at that time, 600,000 books. Right? So we could search and discover books not just by title, metadata, author names, but the contents of the books. And back then, we were doing a lot of interesting stuff around natural language processing. So Amazon invented so-called statistically improbable phrases. These are phrases that are sufficiently unique to a certain small portion of books. In other words, they appear several times across all the books, but not a lot, right? So to be not so interesting. And so you can see that in this book, there's something called opportunity pie or top exit pages. And these are specific terms, specific keywords. And if you're looking at one book, you might actually be able to discover other books that are, talking about the same topic. And then you have capitalized phrases. You could say these are kind of named entities, people, locations, and so on. So again, an ability for you to discover books, and you could also see this as a way of modeling topics, which is clearly in the machine learning domain. We had also lots of interesting statistics like really fun stuff like how many words do you get per dollar when you buy a book? I mean, pretty meaningless, but fun nonetheless. And my next project was Amazon Mobile. I was actually the first engineer to be hired into the team that was supposed to be building mobile applications, and this was the first foray for Amazon at that time. This was 2007 timeframe when I joined. We've started with BlackBerry. In fact, these are BlackBerry screenshots. But as soon as iPhone SDK allowed others to publish their apps, we've switched our attention to iPhone. And one of the features that we've launched with was called Amazon Remembers. The idea is, okay, simple. You take a photo, and if we can find products inside that photo, we will send you a link, and you can buy that on Amazon. Sort of obvious. And when we launched this, this was done using Amazon Mechanical Turk. And later on, we've replaced this with a fully automated system that identifies products that the camera sees. Now, how many of you have heard of Amazon Mechanical Turk? All right, a fair number, right? So it's a weird name, but the idea is, you may recall in Middle Ages, there was this chess-playing automaton that was in the form or appearance of a Turk with a turban that was, playing chess. It was going around the courts and maybe, entertaining the royalties of the day. And of course, the trick was that there was a little person hidden inside that was actually moving the chess pieces, so it was not, automated. And here's the same idea. We have lots of so-called human intelligence tasks, little things that require human intelligence, and for a lot of these, even today, we're still not able to provide fully automated solutions, or it may be cheaper to actually have humans perform them. So Amazon Mechanical Turk brings together the publishers of these human intelligence tasks and lots of people who are willing to work on this. So in this case, here's a kind of a hiring sign photo, right? And the task is to identify certain things, the language, are there people in it, and so on. So very quick and easy for a human to click on some checkboxes and, well, in this case, earn 3 cents for doing this, and then maybe rinse and repeat. But you get the point. Now, this was launched pretty soon after I joined the company, actually, so a long time ago. But it turns out that today there's a great relevance of this tool to machine learning and AI, because you look at the current hits and you see a lot of them actually ask you to annotate images, right? So you take a photo and here's a bounding box around a human, maybe around a car, a bicycle, you know, even parts, body parts like a head. And all of these annotations are then used to train machine learning models to kind of imitate human intelligence. So extremely popular crowdsourcing mechanism specifically for machine learning. Okay, so we often hear that we're in the midst of a new AI revolution, and revolution is a heavy word. It's been used for many things. Maybe you've also heard about the blockchain revolution, right? And with that, I like to show this kind of slide. Often gets a giggle. I mean, it's a joke. Even AWS has some solutions in this blockchain space, so there are real applications there. But it's a little bit harder for everybody to kind of relate to this, right? It's not so tangible. Whereas in something like AI and machine learning, you have some really cool specific innovations that are designed to solve a particular use case. So what you're seeing, of course, is the Amazon Fulfillment Center. When I toured one of these back in Seattle many years ago, we had humans walking from shelf to shelf, picking products. They're called pickers, right? And now, instead of this, we have robots taking the shelf and bringing it to a human station where, the products and orders can be assembled. And of course, you can imagine there's lots of optimization and machine learning kind of problems that relate to this space. Now, you've also heard about Echo and Alexa. At this point, I have Alexa in virtually every room in my house. It turns on the lights. It's a great way to kind of deal with children, right? You set the timer and it's Alexa telling you to stop doing something rather than me, right? So great tool for that. Maybe, only bathrooms are not yet covered, but that's something to think about. And by the way, you get a newsletter if you use this with all the new stuff that comes out, and then you get that pretty regularly. So some of the coolest stuff that came out recently was whisper mode, right? So if it's late at night and maybe your family's already asleep, you can whisper to Alexa, and Alexa then whispers back if it needs to respond automatically, right? You don't need to say anything. It's pretty cool. Of course, when Amazon Prime Air kind of was announced, a lot of people thought it was a publicity stunt, right? And now there's a lot of copycats and a lot of kind of work in drone delivery. This is, like I said, not a simulation. This is real tests. And in fact, of course, it's still hard because of all the regulatory environments around different countries. It turns out that in Cambridge in UK, it's actually a little bit easier to test these things. So these are real tests that are kind of happening today. And again, you can imagine that there are some cool machine learning optimization control problems that are being solved. Now, this is the Amazon Go store. It was launched in Seattle not so long ago. I've gone, every time I go to Seattle, I made a point of visiting. It's a lot of fun. You walk in, you just scan your phone to identify yourself, because then the visual system will then say, okay, well, this person that just walked in, I know who that person is through the code. And now you put items in your bag, you put them back in the shelf, maybe in different locations, and the system tracks everything, assembles a virtual cart, and then as you walk out, no checkouts, right? In no cashiers, in a few minutes you're going to get your bill. Of course, it was great to test it. You come out, you grab a bottle, you drink the juice, and put the empty bottle back and see what happens. Kind of rife with all kinds of interesting testing opportunities. But now there are several stores like that that are open, I think another one in Seattle and some other places as well. So at AWS, our role is to kind of bring that technology, that magic, into the hands of different companies, developers, customers out there. So it's all about democratizing this magic, putting it in the hands of a lot of people, making it easily accessible. So this is the current view of the stack of different machine learning services that we offer. And I will go in detailed way through this in my workshop tomorrow at 2:30. So if some of you are going to attend, please come and check it out. But we look at different hardware, specialized hardware that enables machine learning models like NVIDIA and so on. We have also ready-made services that are available with the call of an API. So for detecting images or detecting objects in images, text-to-speech, speech-to-text, chatbots, translation, so on and so forth. And then here in the middle is the platform where data scientists can build stuff from the beginning, developing the models, all the way to the end of deploying production-ready kind of models. Lots of customers. We could say that probably more ML built on AWS out of the cloud vendors than anywhere else, I would say. And all that stuff actually matters. So just look at some of the interesting use cases, right? There's some law enforcement agencies use recognition for investigation on sex trafficking and missing people. And there were, in this case, Marinus Analytics actually was able to identify a missing person just by sifting through a lot of imagery. So very important use cases. But then there are also tools like Grammarly that check the grammar as you type, and they use TensorFlow models built on SageMaker. We have, of course, self-driving cars. So TuSimple is one of the customers. They're using Apache MXNet, which is an open source deep learning library that is also available through SageMaker. And of course, they're doing some cool stuff with it. And on kind of a different scale, it's healthcare applications. So Arterius is able to, just 15 seconds, figure out the cardiac anatomy of a person. And in the past, it was taking so much more time. So very cool, very important applications. But I thought, hey, it's so easy. We're democratizing things. Why don't I do something with Georgian language I don't speak, right? I just thought, okay, let me try something with SageMaker. And what I decided to do is compute so-called word embeddings. And what's word embedding, you might say? Well, it's basically a translation of a word into a vector in a 100-dimensional space. 100 is just an arbitrary number here. But the idea is that once you do this kind of translation of words, you can then use all kinds of machine learning applications where each word now is just a bunch of numbers. And it's much easier for a lot of algorithms to work on these. And these vector representation of words are actually quite interesting and important to look at. So what I've done is I've downloaded the entire Georgian Wikipedia corpus, right, and applied the word-to-vec algorithm, which is translating each word to this vector using Amazon SageMaker and the blazing text algorithm. And so you get then, for every word in that Wikipedia corpus, a 100-dimensional vector. And now if we take that vector and try to plot it in 2 dimensions, right, just for us to easily see, then we'll just grab the first 400 common Georgian words, and this is the TSNE plot, and this is how it looks like. Now, it's a bunch of dots. If you kind of zoom in, you'll see each dot represents a certain word. And the curious thing about this is that this system has no knowledge of Georgian language, but it's able to understand that certain words are close together because of their meaning, right, and the semantics and the place where they're used in text. So you'd see groupings of words that are used in the same context. And so I analyzed this for some of the groupings just manually using translation. So here we have or ori and erti, and orive is also close by, right? And so these concepts are very similar and close together, so it's quite natural. Same thing with achali and tzveli, right? These are, even though they're antonyms, they clearly work together, right, semantically. And then even more interesting examples where you have Romis Imperis, right, Roman Empire. Again, it makes sense that they appear in the same context. Of course, Wikipedia, probably a lot of history articles and so on, so it makes a lot of sense.